Welcome to GK TechVerse. This is one of the most asked system design interview question. Many developers use REST API daily but don't fully understand what actually happens internally when we call an API. When you click a button, within milliseconds, response will appear. But behind the scenes, DNS lookup happens, TCP and TLS handshakes happen, load balancers route your traffic, your Spring Boot application process your request internally, and your database queries will execute. JSON response travels back to you, and all this happens in a few milliseconds. In today's video, we will break this entire journey step by step, like a system design interview, from client request to server processing and back to the client. If you are preparing for backend interviews or want to understand real world system flow, this video is for you. Before we go deeper, let's quickly understand what exactly is a REST API. REST stands for Representational State Transfer. In simple terms, a REST API is a way for two systems to communicate over HTTP. It follows simple principles. It uses HTTP methods like get, post, put, delete, and it uses URLs to access resources. It exchanges data mostly in JSON format. And most importantly, it is stateless, means each request is independent. It will take the request and give the response. It won't remember your past. Example, your HTTP method is a get and your domain URL and your resources. This simple means give me a user with ID 101. It sounds simple, but internally the journey is extremely complex. Now let's go deep and understand step by step what actually happens when you call a REST API. Here is the sequence diagram which shows you how request and response will travel through a multiple channel. The step 1, the client initiation. It is an originator. A user interacts with a UI or mobile app, or a developer triggers a command from a postman. The flow begins at the client where an HTTP request is constructed. This includes the REST methods like get, post, and the headers with the payload. The client doesn't know where the server is at. It only knows a human readable URL like a api.example.com. Step 2, it is DNS resolution. It is a address book, converting your domain name api.example.com into a machine readable IP address. Since routers only understand numbers, the browser queries a DNS server. Think of think of this as looking up a name in a phone book. The DNS returns the specific IP address of the load balancer or entry point associated with that domain. The step 3 is TCP and TLS handshake. This is the secure connection. Your client will trust you when you provide a secure connection. Once the DNS returns the specific IP address, then this will be establishing a stable encrypted pipe for the data to flow through. Before data moves, a connection must be established first. A TCP three-way handshake ensures both sides are ready to talk. Immediately after the TLS handshake occurs, This is where the client and server exchange the certificates and secret key to ensure that even if someone sniffs the network, they can't read your data. This turns HTTP to HTTPS. This is the place where the data at transit is encrypted and secure. If your URL is not HTTPS or not secure, then there will be a security risk. In real production system, request doesn't go directly to the server. It will reach to the step 4, which is edge layer flow. It's like CDN, API gateway, load balancer. This edge layer will be controls your traffic, and it acts as a security guard which can filter caching and routing the request to the correct internal server. The request hits the edge layer. The CDN checks if it can serve a cached version of the data immediately to save time. If not, the API gateway or load balancer inspects the request. It performs high level security checks like rate limiting, DDoS protection, and then decides which specific Spring Boot instance in the data center is healthy enough to handle the job. Now the request reaches your Spring Boot application. The embedded Tomcat is a web server. Once the request enters the server, it is picked up by a embedded Tomcat. Its primary job is to act as a listener. It converts the incoming network byte stream into a former HTTP servlet request object that Java can understand. Before reaching your code, the request must pass through a filter chain. So we use filter. This is where global concerns like Spring security, JWT validation, cause headers, and request logging happen. If the user isn't authenticated, the filter can reject the request right here. So once the request is authorized, then the dispatcher servlet receives the request. Dispatcher servlet is the front controller. It asks the handler mapping based on the URL and method which controller should handle this. Once the controller is found, the handler adapter takes over. It handles the heavy lifting of data binding, taking URL parameters or JSON bodies and turning them into a Java objects to pass into the method arguments. Next, the actual method in your REST controller is invoked. This is the first time the request hits your specific business logic. Application layer flow. The controller validates the input. It doesn't do work. It simply tells the service layer what needs to happen. The service layer is where the business rules live. It handles calculation, permissions, and coordinates multiple data operations. So it represents a single transaction. And the repository will have mostly Spring Data JPA, which abstracts the database complexity. It translates Java based method calls into SQL queries. And in the database role, the permanent storage, like the database executes the SQL queries, ensures data integrity, and returns the rows back up the chain. Once the data execution happen, so response creation and backflow will happen, which is the final polish. As the data travels back up, the message converter Jackson kicks in. It takes your Java DTO and serializes it back into a JSON string. This response then flow back through the filter chain where response headers are added and out through Tomcat to the server. So next time you call an API, remember, it's not just a request, it's a complete system journey. If you enjoyed this deep dive, subscribe to GK Tech Course for more backend and system design breakdowns. Thanks for watching GK Tech Course. Subscribe and keep upgrading your skills. See you in the next video.